Good afternoon, students. Welcome back to chemistry class. Today we are going to study about periodic trends in atomic radius, variation in periods. How the atomic radius vary in periods. That all today we are going to study. Okay. We know this is the modern periodic table. There are 118 elements are arranged in the periodic table in a very systematic manner. The periodic table consists of 7 periods and 18 groups. Okay. So here some properties having the particular trend. Yesterday we studied about that there are 5 properties: atomic radius, ionic radius, ionization energy, electron affinity and electronegativity. Okay, these are the some properties. This having the different trend. Okay, one of the important property that is atomic radius, atomic size. Today we are going to study about the atomic radius vary in a periods. Okay, so size of an atom also measured in terms of radius. This is called atomic radius. The atomic radius means the distance between the center of the nucleus and the valence shell electron. Okay, what do you mean by atomic radius means? The distance between, this is the nucleus, the electrons revolve around the nucleus in a circular path, that is we called as the shells or orbit. So here, what is atomic radius means? The distance between the center of the nucleus and the valence electron in outermost shell, that is called atomic radius. Okay. Sometimes we cannot measure the radius of an atom directly. We cannot measure the radius of an atom directly. At that time we take 2 or more atoms, maybe more than 3, 4, 5 atoms. But here we are taking the 2 atoms and take the internuclear distance between these 2 atoms. Okay, we take the internuclear distance between the 2 atoms. Okay, wow. So here this is the one of the atom and this is the another one atom. Here this is the nucleus of this atom and this is the nucleus of this atom. Here we are taking the internuclear distance, the distance between the center of the nucleus of 2 atoms, that is called internuclear distance. Okay, so internuclear distance experimentally, that is we taken by the X-ray diffraction technique. And what do you mean by atomic radius means 1/2 of the internuclear distance, that is the atomic radius of a particular atom. Understood? Okay. We are going to study about the atomic radius variation in periods. Atomic radius, how vary in periods. For example, now I am taking one of the example, that is the oxygen atom. You know, the oxygen lies to the right side of the right of the nitrogen in the periodic table. This is the periodic table. Oxygen is present at the right of the nitrogen in the periodic table. So the size of the oxygen atom is bigger than nitrogen atom or smaller than nitrogen atom or equal to nitrogen atom. Let us explain now. Let us try to answer this question. We know all these elements, that is nitrogen, oxygen, all these elements are lying in the same period. What happened across the period? The elements are arranged in the increasing order of their atomic number. So going from left to right in the period, the atomic number increases. Okay, so elements, we know the elements are arranged in the increasing order of their atomic number. So as we are moving from left to right in a period, the atomic number increases, we know. Okay, first we consider the second period, that is lithium atomic number 3 and beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9. Okay, these are the period. Okay, so when we are moving from left to right, the atomic number increases. As atomic number increases, we know the atomic number means the number of protons. Okay, what do you mean by atomic number? That is number of protons or number of electrons. Okay, so as we move from left to right, the atomic number increases. As the atomic number increases, the number of proton also increases. The number of proton also increases. Okay. As the number of proton increases, the effective nuclear charge, the nuclear charge, that is the nuclear charge also increases. Okay, the atomic number increases, the number of proton increases, the nuclear charge also increases. So we know the nucleus consists of neutrons and protons. Okay, neutrons and protons. Neutrons are neutral charge. That is, they have no charge. So the charge of the nucleus depends the charge of the proton only. Okay, the charge of the nucleus depends upon the charge of the proton only. More the number of protons, more is the nuclear charge. Okay, so as we move from left to right in the periods, as the number of protons increases, therefore the nuclear charge also increases. Okay, so as we move from left to right, atomic number increases, number of proton increases, and nuclear charge also increases. This leads to greater force of attraction on the outermost shell. Okay, so this leads to greater force of attraction on the outermost shell. Okay, so number of proton increases means it is the high nuclear charge. Nuclear charge is high at the nucleus and leads to greater force of attraction on the outermost shell electrons. Okay, so the atomic number increases, number of proton increases. As the number of proton increases, nuclear charge also increases. When nuclear charge increases, the nuclear force of attraction, nuclear force of attraction on the outermost shell increases. Nuclear force of attraction on outermost shell increases. The increased nuclear charge tends to pull the outermost shell closer to itself. The increased nuclear charge tends to pull the outermost shell closer to itself. Understood? And it doing so, the atomic size decreases. Understood? The atomic size decreases. Okay, so as we are moving from left to right in the periods, atomic number increases. Atomic number increases, we know the atomic number means number of protons, that is number of protons also increases. When number of proton increases, the nuclear charge increases. When nuclear charge increases, the nuclear force of attraction on outermost shell increases. The increased nuclear charge tends to pull the outermost shell closer towards itself. Okay, so the atomic size also decrease. Okay, let me see our question. What is the question? I told oxygen lies to the right of the nitrogen in the periodic table. So the size of the oxygen atom is bigger than nitrogen atom, smaller than nitrogen atom, equal to nitrogen atom. Which one is the correct? That is, let's see now. Okay, this is the periods. Second period. This is the second period start from lithium to neon. Lithium to neon, you know. So lithium atomic number 3, electronic configuration 2, 1. How many shells are there? There are 2 shells. Okay. Beryllium also 2, 2. Atomic number 4, electronic configuration 2. First orbit 2 electron, second orbit 2 electron. And atomic number 5, that is boron. Here also, how much shells are there? There are 2 shells. Okay, 2 shells. Carbon also there are 2 shells. Nitrogen also 2 shells. Oxygen also 2 shells. Fluorine also 2 shells. And neon also 2 shells. Okay, so from as we move from left to right in a period, the atomic size, we know, we studied about that, atomic size will be decreased, because when atomic number increases, the number of proton increases. The number of proton increases means the nuclear charge increases. Okay, so the greater the nuclear charge tends to pull the outermost shell closer to itself. Okay, here the outermost shell, only 1 electron. The proton, number of proton, only 3 protons here. For lithium atom, only 3 proton. When compared to oxygen, how many protons are there? 8 protons are there. Okay, so when atomic number increases, nuclear charge increases. Okay, when you are moving from left to right, number of shell same, but number of atomic number only increase. Okay, so when atomic number increases, number of protons increases. When number of proton increases, the nuclear force increases on the outermost shell. Okay, so greater the nuclear charge tends to pull the outermost shell closer itself. Okay, and doing so, the atomic size decreases. So as we move from left to right, the atomic size decreases. This is the periodic trends property about the atomic size, atomic radius. Understood? So what is the question? Our question: when oxygen lies to the right of the nitrogen, see the periodic table, the oxygen, it is lies right to the nitrogen atom. So the size of the oxygen atom is bigger or smaller or equal to nitrogen? That is smaller than nitrogen. Okay, smaller than nitrogen, because as we move from left to right, when atomic number increases, the atomic size decreases. Understood? The variation in the atomic size is true for all the periods in the periodic table. How much periods are there? Totally 7 periods are there. All the periods, the same trend is true for all the periods in the periodic table. So when we move from left to right, the number of shells remain same. We know that the period number is equal to number of cell. Okay, period number is equal to number of shell. Here period number 2, from lithium to neon, period number 2. So number of shells 2. Okay, if we talk about the second period, so the number of shells for all atom in the second period having 2 shells. Okay, this is true for all the periods in the periodic table. So when move from left to right in the periodic table, number of shells remain same, because we know that the period number is equal to number of shells. Understood? This is about the atomic variation of atomic radius in periods. Okay, as we move from top to bottom means in the groups. Okay, as we move from top to bottom, the atomic number increases, number of proton increases, nuclear charge increases, nuclear force of attraction all increases, but number of shell also increases from moving from top to bottom. Okay, so number of shells increases, the nuclear forces, the electrons in the outermost shell, it is loosely bound. Okay, there the screening effect they are having. Because of the screening effect, the nuclear charge, nuclear force of attraction become low. What do you mean by screening effect? Now we are going to study. Okay. So here, what do you mean by shielding effect? Shielding effect. Okay. Shielding effect means as we move from top to bottom. As we move from top to bottom means the atomic number increases, but number of shells also increases there. Number of shells also increases there. Because of the number of shell, the valence electron, it is loosely bound in the outermost orbit. Okay. So the loosely bound the valence electron, but also the nuclear charge, nucleus also attract the valence electron. But the inner shell electron, it always repel each other. Because of the repulsive force, the screening effect takes place there. Okay, so what do you mean by screening effect? I am before that, you should know about inner electrons and outer electrons. In the shielding effect, main two important concept that first one, inner electrons and outer electrons. Just first I tell you about the concept of inner electron and outer electrons. We know that positively charged protons present at the center of the nucleus and the electrons are revolve around the nucleus in a circular path. We call this, that is orbit. Okay, here, what is inner electrons and what is outer electrons? You know, here, this is the nucleus. I am taking, this is first orbit electrons. I consider this is A orbit. And second orbit, I consider this is B orbit. Okay, this is A orbit electrons, this is B orbit electrons. Here, the electrons present is strongly attracted by the nucleus when compare the electron present in B orbit, electron present in A orbit. This is the A orbit. So, the electron present in A orbit, it is strongly attracted by the nucleus when compared to electron present in B orbit. Okay, understood? So, here the A orbit is very nearer to the nucleus. So, here nucleus attraction will be high. Okay, so when distance increasing, the nuclear force of attraction decreasing. Okay, distance between the nucleus and electrons will be increased, the nuclear force decrease. Okay, understood? When electrons are nearer to the nucleus attraction will be high. Nucleus highly attracted to the electrons in inner orbit. When distance from the nucleus is high, the nuclear attraction will be low. Understood? As we know, there are two forces of attraction acts upon the nucleus and the electron. Already we studied about that. There are two forces of attraction acts upon the nucleus and the electrons. What are the two forces? That is nuclear force, effective nuclear force or effective nuclear charge, and the repulsive force. Okay, so nucleus always attracts the electrons, that is called a nuclear force. Nucleus, that is the proton positive charge, always the positive charge, opposite charge always attract each other. Okay, so nucleus has the positive charge, electron is the negative charge, so nucleus always attracts the electrons, that is called nuclear force. Okay, the nucleus also attracts the outer shell also. This is the outer shell. This is the outer shell electron. But this nucleus also attracts the outer shell. Okay. But here you know, when considering the A orbit and B orbit, A orbit electrons completely repel the B orbit electrons. Okay, the electrons in the A orbit, it always completely repel the electrons in the b orbit. Okay, these two orbits electron acts as the screen or shield, and it always repel the outermost electron also. This is called the valence electron, the screening effect. Okay, screening effect. So what do you mean by screening effect? The repulsive force between the inertial electron and the valence electron leads to a decrease the electrostatic attractive force acting upon the valence electron by the nucleus. Okay, the repulsive force between the inertial electron and the valence electron leads to decrease the nuclear electrostatic attractive forces acting upon the valence electron by the nucleus. Okay, so nucleus, it acts the electrostatic force of attraction, that is effective nuclear charge upon the electron, but here the inertial it acts as the screen or shield, and it repel the valence electron, so the electrostatic attractive force, it is very low. Okay, thus the inertial electron acts as the shield. Thus the inertial electron acts as the shield between the nucleus and the valence electron. The inertial electrons act as a shield between the valence electron and the nucleus. Okay, nucleus and valence electron, this effect is called the shielding effect. Understood about the shielding effect? Okay, you know this the nucleus. The nucleus always attract the electron, that is called electrostatic force of attraction. So electrostatic force of attraction is very high in the nearest orbit electrons. Okay, so this is called inertial electrons. The nuclear force nucleus also attracts the outermost electron, but the inertial electron acts as the screen. Okay, screen between nucleus and electrons. So then electrostatic force of attraction will be low. This effect is called the screening effect. Okay, so here the net nuclear charge experienced by the valence electron in the outermost shell is called the effective nuclear charge. The net nuclear charge experienced by the valence electron. Okay, how much nuclear charge experienced by the valence electron, outermost orbit electron? That is mentioned one of the equation, that is ZEFF. ZEFF means effective nuclear charge. Okay, ZEFF is equal to Z minus S. Using this formula, we can calculate the effective nuclear charge on the outermost electron. Okay, so here Z means that is the atomic number, and S means the screening constant. The constant value given by the Slater. Okay, Slater, that is called the Slater's rule. Okay, the constant value for the S. S means screening constant. So the constant screening value given by the Slater's rule. Okay, so here what is about the Slater's rule? The Slater's rule that is given by the fourth step. Okay, we can understand about this Slater's rule with an example. I will explain with an example, then you can understand about this. According to Slater's rule, how will you calculate the effective nuclear charge? Students, very important. This it is important for your NEET basis examination, other competitive examination, very important. how will you calculate the effective nuclear charge of a particular electrons in a group. Okay, all of you should note what I am telling. You should write the notes. Okay, according to Slater's rule, what is the first rule? First step, write the electronic configuration of an element. Now I am taking the one of the example, scandium. Scandium, you know, atomic number 21. So write the actual electronic configuration for the scandium, that is 1s2 2s2 2p6, 1s2 2s2 2p6, 3s2 3p6. After 3p, the 4s orbital will come, 4s2 3d1. This is the electronic configuration for the scandium atom. But according to Slater's rule, we can rearrange. Second point, rearrange the lowest orbital to highest. Okay, the lowest to highest, and the group lowest energy level to highest energy level. We can rearrange this electronic configuration from lowest orbital to highest orbital, that is lowest energy level to highest energy level, and group this electronic configuration on the basis of group S and P together. Group S and P we can grouping together. Others, everything, group S and P together. Others, everything else is separate. Others, everything else is separate. Okay, now we are going to rearrange this electronic configuration. You know, the first, this is the nucleus. The first orbit n is equal to 1, second orbit n is equal to 2, third orbit n is equal to 4, fourth orbit n is equal to 4. Okay, here you know, first n is equal to 1 means k shell. K shell, how much orbitals are present? K shell, how much subshells are having? Only one subshell, that is S. Okay, that is 1s2, maximum 2 electrons. After that, n is equal to 2 means which is shell? L shell. How many subshells are there? S and P. Already you know. And n is equal to 3 means M shell. How many subshells are there? S, P and D subshell. When n is equal to 4 means that is N shell. How many subshells are there? S, P, D and F subshells are there. Understood? So we can rearrange this electronic configuration based on Slater's concept, Slater's rule. First 1s orbital, that is 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d and 4f. Okay, according to Slater's rule, the s and p orbitals we can grouping together. Okay, so 1s orbital, how much electrons are here? Only 2 electrons. So 1s 2 first group, and 2s 2p, 2s and 2p, how much electron? 8 electrons, and 3s 2 3p. Okay, 3s and 3p, how much electron totally? S orbital 2 electrons, p orbital maximum 6 electron. So grouping together 3s and 3p, total electrons 8 electrons. Okay, after that 3d, here you should write 3d. Okay, 3d 1, it is grouping separately. Okay, and after that 4s2. This is the according to Slater's rule, that is second rule. First one, you should write the electronic configuration of an element, and second, rearrange the lowest orbital to highest orbital, and grouping S and P orbital together, and remaining everything else is separate. D, F. Okay, we can separately grouped. Okay, and third point, what is the third rule? Which electron are you calculating the effective nuclear charge for? That is select. Select, third rule, select the electron in a group have to calculate the effective nuclear charge, that is ZEFF. ZEFF means effective nuclear charge. Here you know one of the formula, ZEFF is equal to Z minus S. Z means atomic number of an element, S means screening constant. Okay, screening constant we don't know. Okay, for calculating screening constant we are using this letters rule here. After calculate the screening constant, we can calculate the effective nuclear charge of an electron in the orbital. Okay, understood? So second point is select which electron in the group have to calculate the effective nuclear charge. Here let us calculate the effective nuclear charge on 4s electron of the scandium. Okay, I am taking the example scandium. I am going to calculate, first upon I am going to calculate the 4s electron of the scandium atom. After calculating 4s electron, I will calculate the 3d electron of the scandium atom. Understood? So here, one of the rule here, for some D and F, suppose suppose I am calculating the S and P orbital. Here certain rules. What are they? First upon I am going to calculate the 4s orbital. Okay, 4s electron in a scandium atom. Okay, for S and P orbital in the any atoms, for S and P orbital, to calculate the effective nuclear charge for S and P orbital, here having some of the value given by the Slater's rule. Okay, which of the values? That is, now I am going to calculate suppose I am going to calculate the 4s electron. So this 4s, this is the outermost shell. Okay, I consider this is the outermost shell, that is the nth shell. Okay, nth shell. And before the outermost shell, this is the ultimate shell, and before the outer shell, that is called the penultimate shell, that is we call as n-1 orbital. Okay, before the n-1 orbital, the inner shell, that is n-2. I am taking n-2. And before the n-2, I am taking, this is before the n-2 orbital, that is n-3 orbital. This is the inner shells. Okay, so outer shell I am consider nth orbit. Okay, so 4s2 electrons they present in nth orbit. I am going to calculate the effective nuclear charge of the 4s electron. So I am taking this is the nth orbit. Okay, so here some values given. What are the values? That is 0.35 for each electrons in the same group. Which group I am going to calculate the effective nuclear charge? So that is we taken as the nth orbit. That is the value given by 0.35 for each electron in the same group. Okay, what is the value for nth orbit? 0.35 for each electron in the same group. Those which electron I am going to calculate, I am taking that is nth group. What is the value for nth group? 0.35. Okay, and this point number 1 and point number 2. For 0.85, this another one value, 0.85 for each electron, one shell lower the orbit. Okay, very important. All of you should take notes. Okay, then only you can understood. 0.85 for each electron, one shall lower the orbit. Okay, now I am taking this is the last orbit, nth orbit, that is 4s orbit. there is what is the value for nth orbit for the s and p orbital? Okay, only this is for s and p orbital. Only we are calculating, when we are calculating s and p orbital, only these values given. 0.35 for the each electron in the nth group. Okay, so nth group I am taking 4s orbital, I am taking the nth group. Okay, so one shall lower the orbit, there is n minus 1 orbit. Okay, so n minus 1 orbit, what is the value given? 0.85. Understood? And finally, point number 3, 1, what is the value? 1.00 value for each electron other inertials. Okay, 1.00, what is the value for 1.00? For which values this? 1.00 values for each electron other inertials. What are the other inertials? n minus 2, n minus 3, n minus 4, other. How much inertials are there? For all the inertials. Okay, for all the n minus 2, n minus 3, n minus 4. Okay, here only n minus 3 only having here. For scandium atom only n minus 3 orbits only having. Okay, for this is the I am taking the 4s2. It is the nth orbit. Okay, I am taking the nth orbit, and 3s2, 3p, 6 and 3d. Okay, this is 3s, 3p, 3d. It is present in one orbit. Okay, which orbit? M orbit, n is equal to 3. Okay, so I am taking, this is n minus 1. I am taking this n minus 1. Okay, before the last nth orbit. Okay, one shall lower the nth orbit. That is, I am taking n minus 1. Okay, and 2s before the m shell, before L shell. L shell, how much orbitals are there? 2s and 2p. 2s and 2p orbital, I am taking n minus 2. N minus 2. Okay, after that remaining n minus 1, that is 1s 1 orbital, I am taking n minus 3. Understood? Okay, on the basis of this order, here for the last nth orbit, I am taking 0.35 value. 0.35 for each element. Each and every element in the nth orbit. Okay, for 0.85 for each electron, one shall lower the orbit. One shall lower the nth orbit. That is n minus 1. Which orbit? n minus 1. N minus 1 orbit. What is the value? 0.85. Okay, and the n minus 2 and the remaining other all inertials, what is the value given? 1.00. 1.00, n minus 2, n minus 3. Okay, all the other inertials, what is the value given? 1.00. Understood? So I am going to calculate now. This is the effective nuclear charge for the 4s2 group of the scandium atom. Okay, so first upon, what is the n value? What is the n value? I am taking the 4s2. Okay, last orbit, I am going to calculate the effective nuclear charge. Okay, and 4s2 group. Okay, so remember one of the, according to Slater's rule, that is second rule of the Slater's rule. What is the rule having? Which group we are select to calculate the effective nuclear charge, you should subtract 1, okay, 1 electron from that nth group. Okay, for the nth group, how so much electrons? Suppose 3 electrons or 4 electrons or 5 electrons. Okay, how every electrons. Okay, here only 4s2 electrons are having. Okay, we should subtract 1 electron from total electrons of the group. Okay, so for the we are going to calculate the effective nuclear charge on 4s orbital, 4s group. How much electrons are here? 2 electron. Okay, 2 electron. So we should subtract 1 electron. Okay, from the forest group. So 2 minus 1 is equal to what is the value? 1. Okay, understood? So I am taking 1. How much electrons for nth orbit? Totally 2 electrons. We should subtract 1 from the last nth group. Okay, so n value, how much electrons? Okay, n means what is the orbit group? Okay, which group? Nth group. How many electrons? Number of electrons in this group? 1. Okay, and the contribution of each electron for the S value. S value means latest value. Contribution of each electron. What is the S value here? For the nth orbit, for the S and P orbital, the nth group, what is the value? 0.35 for each and every electrons. Okay, here only one electron there. Okay, and secondly, n minus 1 group. N minus 1 group. Which one is the n minus 1 group? Here 3s and 3p and 3d. 3s, 3p, 3d. That is the n minus 1 group. Okay, how much electron? Total electron? 8 plus 1, 9. Totally 9 electron present in the n minus 1 group. Okay, here you should not subtract the electrons. Only last nth group electron only we should subtract 1 electron. Okay, so n minus 1, the group name n minus 1 group. Now how many number of electrons in n minus 1 group? Here totally 9 electron. What is the value for the n minus 1 orbit? 0.85. Okay, understood? And other inertials. What are the other inertials? N minus 2, n minus 3. Okay, n minus 2 and n minus 3 inertials are there. These inertials we are taking together. Okay, others, n minus 2 and others. What is the group name? N minus 2 and others. Totally how much electrons? Here n minus 2 total 8 electron and n minus 3 2 electrons. Totally 10 electrons. Okay, what is the value given here? Only 1.00. That is 1. Okay, understood? Now we are going to multiply this number of electrons and S value. Okay, number of electrons, this is the, because of the, this is S value for each and every electron for this group. Okay, so here for the nth orbit, totally 2 electrons are there, 1 left and only 1 electron remaining. So we can multiply from 1 into 0.35, we get 0.35. Okay, and n minus 1 group, 9 into 0.85, what is the value? 7.65. And 10 into 1, 10. Okay, so when adding these 3 values, we get 18. By adding these 3 values, we get 18. Okay, this is the S value. Total S value for the scandium. Okay, where we calculated the effective nuclear charge on, we are going to calculate the effective nuclear charge on the 4s orbital. Okay, 4s orbital. So this is the S value. Okay, here what is the effective nuclear charge formula? Effective nuclear charge is that EFF is equal to Z minus S. Z, what is the Z means? Atomic number of scandium 21 minus what is the S value here? 18. So 3. Okay, effective nuclear charge for the effective nuclear charge experienced by the last nth orbit, that is 3. Understood? Okay, this is effective nuclear charge means, what do you mean by the effective nuclear charge? The net nuclear charge experienced by the valence electron in the outermost shell. Okay, the net nuclear charge experienced by valence electron in the outermost shell, that is called effective nuclear charge. Okay, here we calculated the effective nuclear charge experienced by the last 4s orbital. How much effective nuclear charge experienced? Inertials are experienced very high effective nuclear charge. Here 4s orbital, last orbital, how much effective nuclear charge experienced? Totally effective nuclear charge experienced by the last 4s orbit, that is 3. Understood? And secondly, I am going to calculate the effective nuclear charge on 3D electron in scandium. Okay, this is the scandium atomic number 21 electronic configuration. This is the grouping of this electronic configuration according to Slater's rule. Now we are going to calculate the effective nuclear charge experienced by the 3D orbital in scandium atom. 4s orbital we completed, that is 3. Effective nuclear charge experienced by the 4s orbit, that is 3. Okay, and now I am going to calculate the effective nuclear charge experienced by the 3D orbital in scandium atom. Understood? So what is the rule here? First we grouped the elements, that is n-3, n-2, n-1 and n. And first, what is the according to Slater's rule, first upon we should select the electron in this group to have to calculate the effective nuclear charge. Which electron we are going to calculate? That is 3D electron. Okay, here one of the rule, that is according to Slater's rule, step 2, identify the group in which the electron of interest is present. The electron present right to this group does not contribute to the shielding effect. Okay, I identify the group, that is 3D group, to calculate the effective nuclear charge. Okay, I choose the 3D group to calculate the effective nuclear charge. So according to Slater's rule, the right to this group does not contribute to the shielding effect. Okay, understood? So the 4s electron, it is it does not contribute to the negative nuclear charge. Okay, understood? So I am taking, this is the nth orbit, 3D electron, 3D orbital. I take a 3D group, I am taking the nth. I am going to calculate the 3D electron. Okay, effective nuclear charge for the 3D electron. So I am taking, this is the nth orbit, last orbit. Okay, at 3s2 3p6 I am taking n-1, and 2s2p I am taking n-2, and 1s2 I am taking n-3. Understood? So I am, according to this rule, here also for the D and F electron, okay, for calculate the effective nuclear charge for D and F orbital, here different rule given. Okay, what is the rule here? 0.35, the first is correct, 0.35 for each electron in the same group, that is nth group. Okay, 0.35 values, that is for the nth group of the orbital. Okay, here, and secondly, one for every electron in any other lower group. Okay, but here SNP orbital, the n-1 orbital we take 0.85 for the each electron for the n-1 orbit. Okay, but when we are calculating D and F electrons, we are calculating, suppose we are calculating the effective nuclear charge on D and F orbital, we take the 1, okay, 0.85 you should not take. Okay, you take the 1 for each and every orbital for the every inertials. Okay, so 0.35 is given for the nth orbit. So all the other inertials for n-1, n-2 and n-3 and others, n-1 and others, which is the value given 1.00. Okay, so let us calculate for the group name N, how much electrons are there? 3D1. How much electron? Only 1 electron. Remember, we should subtract 1 for the total number of electrons in the nth group. So 1 minus 1, 0. Okay, so n value it is 0. So what is the value for nth orbit? 0.35. Okay, and n-1 and others, n-1 and others, the value given 1. Okay, total number of electrons, how many electrons are here for the n-1 and others inertials? Totally 18. 8 plus 2, 10, 10 plus 8, 18 electrons. 18 electrons. So 18 into, what is the value given? 1. Okay, so 18 into, so we are multiplying 0 into 0.35, 0. 18 into 1, 18. Okay, so we get 18. For the S value it is 18. Understood? S value 18. So the effective nuclear charge ZFF is equal to Z minus S. What is the Z means? Atomic number of scandium 21 minus screening S value, that is S18 for the 3d orbital of the scandium atom. 21 minus 18, we get 3. Okay, what is the effective nuclear charge value for the 3d1 orbital for this atom, that is 3. Understood? These are the calculating the effective nuclear charge. Okay, students, understand? Okay, so today I hope all of you understood. So today assignment, there are 2 questions I will give today. What is screening effect? Important question, book back question also. What is screening effect or shielding effect? And what is net nuclear charge effective nuclear charge? What is effective nuclear charge? What is screening effect? What is effective nuclear charge? Understood? And one more question, that is page number 82. Evaluate yourself. Calculate the effective nuclear charge on a 3p electron in aluminum and chlorine. You should calculate. If you have any doubt, you ask me. Okay, if you have book, take now. Students, take page number 80. What do you mean by shielding effect? First question. The effective nuclear charge heading, 4th line onwards, you mark now. The repulsive force between the inertial electrons and the valence electrons leads to a decrease in the electrostatic attractive force acting on the valence electron by the nucleus. Thus, the inertial electrons act as a shield between the nucleus and the valence electron. This effect is called a shielding effect. And second question, what do you mean by effective nuclear charge? The answer is the last paragraph. The net nuclear charge experienced by valence electron in the outermost shell is called the effective nuclear charge. It is approximately by the below mentioned equation. EFF is equal to Z minus S. Okay, where Z is the atomic number and S is the screening constant. Understood? Up to here you mark. And another one question, page number 82. Using Slater's rule, calculate the effective nuclear charge on a 3p electron in aluminum and chlorine. Okay. Okay. And explain how these results relate to the atomic radii of the 2 atoms. You should do this. Try to do this calculation. If you have any doubt, you ask me. Okay. Otherwise, I will explain next class. Okay. Thank you, all of you. Thank you.